Our objective with our time today is just to share some of the thinking around the opportunities and challenges associated with digital transformation for universities, how they can partner with industry, again, as I said, to be more efficient and effective in how we prepare the future workforce and address some of the needs and challenges there. So I'd like to start off, the first question I'm going to direct to Barry Cohen.
See what I mean?
He knew this was coming. I already told him. Don't let him fool you.
Well, she told me.
That's true. So as I mentioned, I actually didn't introduce myself. My name is Alyssa Walker. I've been with PTC for 5 years working in the academic program. I'm actually the director of academic marketing and outreach within the group, and have fulfilled a few different roles in my time within the team. But as I mentioned before, the academic team actually falls under Barry's strategy organization. And in my time working at PTC, have learned that Barry is quite good at identifying opportunities and threats, which makes sense as our strategy officer for the company. And so I'd like to ask you, Barry, to share what you feel are some of the greatest opportunities and threats associated with digital transformation with respect to universities and education.
Okay, thank you.
Use your mic.
Use it. Is it on? Oh,
Yeah.
all right. So I think there's always been a gap a little bit between how people get trained in universities and their readiness to do work in the industrial space. And a lot of times that has forced industrial companies to start their own educational programs to close that gap. Well, that gap in some ways has gotten much wider, because the technology that's being created through IoT and augmented reality are technologies that's much more disruptive to the industry. So the whole world of manufacturing is changing dramatically. Everybody knows about Industry 4.0 or about IoT. So there's no company in the world that's going to be able to do things the way they did them before. And the interesting thing at this point in time really is this idea of how some particular technologies affect universities, because what augmented reality does is really change the equation for human productivity. I mean, human productivity and this idea of how do you capture the expertise of workers who are retiring, or workers who can do things better than other workers. And so therefore, universities have a tremendous opportunity to play a role in that transformation through the education of their students, through the idea of how do they get ready to be more productive when they enter the marketplace, and how do they use that technology in order to become more productive. So I think there's a great opportunity and a great threat there. And also, I think we all know that alternative ways of doing education are starting to predominate, whether they be MOOCs, whether they be micro-learning, online courses, and things like that. No, I don't think there's been any time in the university's sort of historical perspective where they've required to change more than they need to change now. And the problem with any institution, and particularly universities, they're not that quick to change. And we have it in our company to some degree, the idea of stovepipes, but in universities, those stovepipes, I think, are fairly firm. And the new world requires a level of collaboration between functions and roles that we haven't seen before. So I think both the opportunity and the challenge is quite great.
Great, thank you. Any additional comments on that from the panel?
Totally agree. What he said. Well, actually, you're a little kind, I think, in your comments about higher ed and being able to prepare the workforce not only for today, but also for the future. As you know, many companies, they spend 6 months a year just getting recent graduates up to speed in whatever their business or industry might be, and that's been going on for decades, and we really haven't responded to that. And it's time to make a change, and the problem is that for many years to defend higher ed, at least a little bit, is we've been changing, but it's been very incremental in nature. The problem is that society and the technologies have not been advancing incrementally. They've advanced much more than that. Call it Industry 4.0. I call it the Industrial Revolution 4.0. And we are just faced with a totally different world. I'm going to ask everyone in this room a question. Is there anyone here who's not connected to the internet? Think of the power and what you have, and also what is being done with your device that's being tracked. I mean, we are living in a different world, and most people don't realize it. We think we're still kind of in this computing age or whatever, but we're way beyond that, and that's part of the problem. And so what we're trying to do at Purdue is basically blow up the system. The Polytechnic Institute, which is a college that was existing at Purdue, we've totally transformed it, and it's transformed so that it's really the convergence of engineering, computer science, management, and the liberal arts. And that's what we're attempting to do, is rethink what higher ed should be like, because higher ed in this nation was created in 1900, based all the systems and everything that we do. It's not 1900 anymore. We're a long, long way from that. The idea of standing up and lecturing and pushing a huge number of students through the system so they can get a job and work for GM for 30 years is not happening. And that stopped happening a long time ago, and that's the challenge that we have. So, yeah, I had some comments.
Yeah. So actually, one of the questions that I was going to pose to you, Gary, was if you could talk a little bit about the smart manufacturing minor, that initiative that you're leading, and your experience in collaborating with industry to develop that.
First of all, I need to warn you, Alyssa, that you need to learn something. Don't ever put a microphone in the hands of a professor in front of a crowd.
Brian, I'm going to count on you to...
First thing that happened.
I think it's even worse when it's a revolutionary professor.
Yeah, I know. So I'll do my best to limit myself, but please,
At least he's self-aware, right?
Yeah, there you go. So we've created a smart manufacturing minor. That's the first step to actually go to a major. Our college has been pretty active in the manufacturing. We've had degree programs and minors for a number of years, but this is truly taking Industry 4.0 and implementing it. And so one of the things we're going to create is what's referred to as a learning factory. And there's an International Association for Learning Factories that was developed in Europe, and we've aligned ourselves with them. But the whole idea is that in this minor, students will actually design and produce a product and go through that whole process in an Industry 4.0 environment, and then learn from that and iterate on it. And so this is not a one-semester experience. It's really across the entire minor, which is probably going to be across 3 or 4 years of their learning. And that's what we're in the process of building right now in partnership with PTC, Microsoft, and Rockwell.
Okay. Brian, as someone who has experience in manufacturing and also now a strong CAD focus, I would love to hear some of your comments on this idea of a smart manufacturing minor and the role that CAD and engineering plays in that.
Yeah, so I first of all, amazing, really, because one of the things that I face when I talk to our current customers, that in their defense, they're worried about trying to get work done now. They have a lot to do, and it's hard to transform in the industrial space as well, although it is happening. I think Barry's right that they must maintain their competitive edge and so forth. It is happening. It is going to happen. But I have come to the realization over the last few years that when my customers ask me about Creo experience leaving university, I think they're already asking the wrong question. It's about learning what Dr. Bertolini, it's with an I at the end.
That's right.
Yeah, what Dr. Bertolini's, it's about learning the process of delivering a product to market in the modern industrial 4.0 world. It's about the thought process. It's not about picks and clicks in a tool. We do have world-class CAD software, and if you learn to use it really well, you're going to create tremendous models that'll be really robust and will enable the digital thread. All true. But if they come to the workplace not understanding how products are delivered to market in a modern world, they still got to learn all of that and the picks and clicks. Well, the picks and clicks are, you can learn that, you can get that. So I really feel like when I ask customers, don't worry about that. I ask customers to not worry about that so much, and instead try to understand what the student has learned from a thought process on what it means to deliver a product to market. What is the process in the modern world for delivering a product to market? Like, what are the thinkings you have to have? Can you actually collaborate effectively across disciplines? I have 2 college-age kids right now. I've done more college visits than I care to count in the last few years. And the word interdisciplinary was uttered many, 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 many times. And I see a big gap in terms of what the colleges are saying they need to be able to deliver and what I still see happening in industry. There's still a lot of work to do there. And I think it starts with thinking differently about, in the way that Purdue is thinking differently about the mindset of what it means to deliver a product across all disciplines in today's world. I think that's a great, great program. I wish I knew about it sooner.
Great, thank you, Brian. Any other comments from the panel?
Yeah, I just wanted to build off that. When we think of the integration of these new technologies and the skill sets that go with them, there are really 2 distinct cultures. There's the IT culture and the OT culture. And bringing those together within our own customers and within our own company is challenging enough. So part of that is the technology piece. The other part, I think Brian and Barry were pointing out, is really the culture that goes around that to enable that and to enable the fruits of that integration. And so you have that going on within companies, but that's also happening at the university side as well, across those stovepipes, so to speak. And that's something that I'm so pleased that Purdue is actually forcing that whole discussion and really blowing it up, as Dr. Bertolini put it, because if you don't do that, you don't get the change and it just becomes incremental. So the cultural aspect is really super critical for us in industry to really develop that talent. So, engineering, design thinking, the process that students go through, the way they collaborate, the cross-disciplinary collaboration is actually very critical. And that's something that we don't see enough of at universities. They just aren't really enabled to really put the pedal down and accelerate that change.
Great, thank you.
So Michael said something that's critical to recognizing the difficulties that we have with implementing Industry 4.0 or smart manufacturing. It's the merger of operational technology and informational technology. And the problem that we often see, especially in an IT-focused area like this, is that it's easy to assume that I can take anybody with great knowledge of IT and allow them to go do smart manufacturing. And that's not the case. I have to spend as much time teaching the operational technology side, which is all of the traditional manufacturing processes or the mechanical processes. I cannot simply ignore the fact that, or I can't take a computer science major or an information technology major or even a data analytics person and pull them in and expect them to understand anything about a process to a point, especially only at an undergraduate level. So there's this critical need to say, hey, we have to be able to make changes and understand how to move the digital thread through the entire design, but you can't simply throw out all the traditional engineering discipline, or you'll end up with a bunch of IT students that don't have the fundamental understanding of the operational side of the technology to be effective at actually delivering and developing the product. Unfortunately, the products aren't smart enough that we can simply ignore the operational side of things. We can't simply move to a technology piece as a solution. We have to have students and employees that understand both sides of that picture. And the critical piece with that is not so much how do we transform to be able to embrace the new technology. It's how do we still get the fundamental knowledge that they need in operational technology while also getting them the additional information. And it's hard to fit that into the same kind of package that we've traditionally looked at, which is why doing things like the minor in smart manufacturing enables students not to do less in one area, but to add additional things in and specific technical expertise. I think we're seeing a lot of programs around the country start to allow engineers in their senior year of their curriculum to specialize in particular areas, whether that is in digital transformation and smart manufacturing, whether that's in some specific operational expertise. You see a lot more of that customization within any engineering program because of the required specialization that's being enabled by technology.
Thank you. Benoit, I'm going to invite you to comment on that.
Yeah, in my understanding, it's regarding the challenge of digital transformation. It's very important to have a strong partnership with industry, because in fact, as academics, we have all the scientific background, all the disciplinary expertise, and so on and so on. But it's very important that people from industry highlights where are the new challenges in technology integration, in the mechatronics development, in the implementation of new concept of cyber-physical systems. Then we need to mix all the technologies we well known, but disciplinary organization and understanding in the academics field. And we need a cross-disciplinary way of doing things and learn our students in a way of practice, and and then learning the basics, they go in the practice and they try to set up by themselves some robots based on all the IT support they can have to develop. And it's very important that we have this close cooperation with industry. It's my main purpose, and in France, I'm the leader of an academic group on Industry 4.0, and we share a lot of this debate, and sometimes it's difficult to have the right connection with industry, because in France, we are not organized like in US or in Germany, where there is some strong connection between both sides of the industry and academics. Then it's a good challenge, but very interesting to do in France.
Thank you. Barry, would you like to comment on, on Benoit's comments around how the role that industry plays in interacting with universities, or what's your vision for industry interacting with universities in this initiative?
Well, hi. So it's a very interesting question. One thing is, how much can you change the institution totally from the inside versus how much do you have to be on the boundaries or outside the university to make that switch? I'm very bad with names, so I'm not going to try to say Dr. So-and-so. I'm just going to say Gary. Okay, and that point there is, and I've seen that model a little bit, and I know that they're trying to do that at Occam. I've seen that done at Warwick University. Is, can you set up an institution basically that's within the boundaries of the university, but fundamentally involves the industry in that presence? It's having a separate, whether you call it a learning center, whether you call it a center of excellence, where universities and industry, and a lot of times even government, can participate in an environment that shows how it can be done if it's being done correctly. Because it's very, very difficult to change fully within the university setting. And the other thing is the speed of change, because most academic programs take years. Industry moves a lot faster than that. And you can prepare somebody for something that you think is going to be there, but if you don't have a close living connection every day with how the changes are happening and that flexibility to respond to it, then even if you're well-intentioned, you're not going to produce students that are really ready for the new world, because that time gap is too big. So I like the Purdue model that is being explored, and models like that I think very important to have that happen. And I've seen that model work, I guess. So,
thank you. Gary.
You're my trigger this morning, so apparently.
I'm glad we set you two apart, I guess.
It's Bertolini, by the way, so if that helps.
Well, I got Gary.
Yeah, that's good. That's the easy part.
Let it be known.
So again, you're very accurate in your comments. I tend to joke in public settings occasionally that I'm actually 35 years old. I've just aged 30 years trying to do what we're doing at Purdue, which is literally blow up the system. And you made a comment earlier about the silos. So these silos in higher ed are actually hardened silos on top of it. And it's extremely difficult to break down those silos, and that's one of the challenges that we have. There's also this constraint of the credit hour, which was invented at Cornell University in 1906, and we're still stuck with that. And it's called the Carnegie Unit because of Dale Carnegie was on the board at the time, and it was set up to create a retirement system for faculty. It had nothing to do with learning, and here we are 115 years later constrained with the credit hour, and so that's a huge challenge. And so what we've tried to do is break down that also, but it's not easy because transcripts are written that way. You can't get into grad school if you don't have a GPA, and I mean, the whole system's rigged against you trying to do it, and so your comment of changing from within is extremely difficult. But there are people that are trying it, and I urge industry to really get behind these efforts, because if you have at least some examples you can point to, it helps others move to where they need to be. And I'm working with a group at Boston College right now they're going to create a new engineering program there, and they're trying to, start from scratch, and they have a real advantage in doing that. I even told them, I wish I had your job, because what I had to go through for the last 6 years has been extremely painful, and we're still not there. I mean, I've been trying to get this advanced manufacturing program at Purdue the way you're now seeing it for at least the last 5 years. And I'm a dean, and I'm supposed to be the boss, right? And so it's very, very difficult. And so there's a lot of challenges, but again, I urge industry to get behind any effort and help them, help them to realize what needs to happen, but then also be there to help them through the process of that change, and stick with those that you think and can have confidence that they will stick with you, because that's what I've seen in higher ed so many times is people simply give up after a while. Or you give them money, and then once the money runs out, nothing really changes. That's how Olin College started, by the way, if you read the history of it. And they're one that started from scratch, and they've been able to do all kinds of really good things. I'm not sure I said anything profound there, but it's very, very hard.
Thank you.
Maybe I can just be a little bit more specific. So when Rockwell's working with the university, we typically work with the engineering faculty because that's where the greatest concentration of the skill sets that is of interest to us. But we're really looking for a combination of those skill sets with computational sciences, with informational sciences, with the business college as well. And so, that's a whole series of stovepipes in and of itself. So one of the questions we would ask when you're working with the university is, do you have an academic advisory board that's cross-functional? And in most cases, the answer is no. And if they do have one, it's not functional, or it's not constructive, and it's not impactful. So, from an industry perspective, that's what we're dealing with when we work with the university. So it makes it really hard, and it does require a significant effort to really shift that course for a university.
Thank you. Yuri, I would love to have you share a little bit more about your experience, first in industry, now at the university level, the transition that you made, but your experience kind of working from both sides of the fence in these different efforts.
So in industry, I'm a world-class expert in operational technology. I won't go into which or what, but that is my area of expertise. And so one of the challenges that we were seeing is students lacking the ability to both understand the operational side of the technology and the ability to grasp how the control side and really the functionality of how we ought to be able to implement sensors and design in the overall process. So that whole idea of the digital transformation, being able to look at predictive models that can tell us what's going on and where that operational technology should be, we were just seeing students fall short. We were seeing students that could come out and do material characterizations out of material science programs, but didn't know anything about the operational side. And we saw people that understood the operational side, but didn't know anything about characterization or anything about the informational side of how to actually do the controls. And that stovepiping to some degree was a real challenge. In fact, in inventing new technology, and we'd put out patents for new technology and demonstrate the capability to do things, and companies were falling flat on their face because they couldn't find people that understood the technology well enough to implement it on the factory floor. And so I played with that for almost a decade, where we would roll out new technology, and unless we would leave our companies to go work with those companies to implement them, it just wouldn't go anywhere. And in looking at that, the goal was to go back to the university and actually engage with students in such a way that we could get them to understand the entire portion of that. And that really does require a challenge, and we've seen that here. When you try to look at the fact that they need to understand pieces from data analytics, and they need to understand a whole lot more about computer science and IT than traditional engineering students do. It was an opportunity to go in, and BYU allowed us the opportunity to go in and make some significant changes to the curriculum. And we were able to do that in such a way where we could, in many ways, redesign how we're offering subject matter to students, especially around this area in digital transformation. It allowed us to move classes that we were teaching to the seniors down to sophomores and juniors, and allow us to add new coursework in after that, to where students could really see pieces of that digital thread from the time that they come in their introductory class all the way through their senior year. And then we had to add additional graduate credits in advanced topics in data analytics, just for our manufacturing students. It also required that, and everybody seems to be saying it, every single level of an engineering program now is embedded with computer programming, and it's hard to separate those. They're learning new languages and everything, and sometimes that's ladder logic for PLCs, and sometimes that's object-based orientation programming that they're learning just to be able to go write other code in different unique places. Sometimes they're learning how to write mashups in ThingWorx, and sometimes they're learning parametric design in CAD programs. And so there's so many different things that they have to learn, but having that opportunity to come back and somewhat instigate that change was really the driving force for why I wanted to come back into academia and see if we could make that change. And I think it's enjoyable. You know, we have people in the audience that are making major changes. We have minor changes being discussed here. We have coursework changes that we're doing within our majors at BYU. A lot of the universities are recognizing, not only nationally here in the US, but globally we're seeing these changes, where we're recognizing that we can no longer simply teach the fundamentals of any given major, but that in order to deal with digital transformation, students have to not only deal with interdisciplinary teams, but they have to deal with transdisciplinary education that covers multiple aspects. And we have to give them the freedom to do that in an academic setting, which is, as Gary said, is not something that we traditionally do. We stovepipe them into a particular curriculum with a certain amount of credits, and breaking those walls down is difficult, but it's a battle worth waging. And so I think we're trying to do that all the way around.
Barry?
No, one thing that stands out to me that's really important is this idea of the exemplar, and what we're seeing, I think, like with Purdue, PTC, Rockwell, and I think Microsoft's involved in it as well, is that how do you get people with a common mindset that have the passion and the capability to change things? You know what I mean? You can't change things by yourself, and this whole idea of if something important is going to happen, then really good people have to get together and collaborate, just like we're asking people to collaborate in industry. And I think that's, for me, one of the hopeful signs, and even one of the hopeful signs that some of the things we've been involved with, and Jordan's been involved with, Jordan Cox, who heads our academic program, we stole him from the university so he can speak the language to us of what a university looks like. And it looks like Yuri's a spy that's come in from the industry. But the idea really is this idea of getting a critical mass of people who come together, who really work together and are part of a larger network, whether it be the network that you mentioned. And I think that makes change, I do believe that makes change possible. So one of the things you asked me about hope or opportunity, it's the opportunity that people from these different walks of life are coming together really and making a commitment to each other to solve the problem, because it can't be solved, on a small scale by individuals. So I think, that's one thing I'm getting out of also being involved here now, because I hear that sort of message of collaboration coming out.